Alright, so we were working through the values of BA given F and a carry of 4. Since if U is 9, then we would carry the 4, and then F would be, we'd have 5 times F plus the carry. Alright, so let's finish that up. So 5 times 4 is 20, plus the carry would be 24. Right? 5 times 6 is 30, plus the carry is 34. And we'd have 39 and 44 and 49, right? Alright, so let's eliminate some of these. Now obviously we have already used the number 1. Okay, so if n is 1, then neither b nor a can be 1, so anything down here that has a 1 in it, we can eliminate. Same way with 5, same way with 9. Anything with 9 in it can be eliminated because this is assuming that u is 9. So that means not 39 and not 49. Alright. So let's see, what else can we eliminate? Okay, so here we had f was 4 and BA is 24. So that's not going to work because that would mean F and A would be both 4, and we can't do that. And here 44. We can't have 44 because B and A have to be distinct numbers, distinct digits. So it looks like the only one that's going to work here is 34. And that satisfies our criteria that A is equal to 1, or A is equal to 4, I mean. So here's what we have in that scenario where we have an A of 4. Let's write out all these numbers. F, U, N, B, A, L, L. Okay? So in this case, we have B and A is 3 and 4. So this is 3, this is 4. And we already said L was 5 and 5. And in that case, F is 6. Okay. U is 9. Alright. And N is 1. Okay, so the problem that works, this problem that satisfies all the conditions of this statement is that we have 691, 691, 691, 691, 691. We add those all up. We have 5, and then this is 45, carry the 4, and then we have 30 plus 4, which is 34. Okay? And this is the set of numbers that satisfies our fun equals ball. Okay? So, and that's when A is equal to 4. Okay, that was one of the conditions up here. But it looks like there are actually, in addition to this one, there are 4 other solutions, and we can just write those out. So let's look at this first row. So here we have F is 9. Okay, U is 3. N is 1. So we have 931, 931, 931, 931. And that's going to give us 5, 5. We carry a 1, it's 45, and that gives us 46. 4655. Alright? That satisfies the equation. If we don't worry about what A is. If A can be any number as long as it's distinct, then this also satisfies the equation. And then it looks like we have 3 of them here. So, in this case, F is equal to 4. Okay, just following this down here. And let's see, U is equal to 7, N is equal to 1. So we have 471, 471, 471, 471. Oops. And and we get 5, 35, carry a 3, that's 23. So that one satisfies it as well if a does not have to be equal to 4. And then we have, let's see, we have this one. So f is 8, u is 7, and n is 1. So we have 8, 7, 1, oops, 8, 7, 1, 8, 7, 1, 8, 7, 1, 8, 7, 1. That gives us 5, 35, carry a 3, 43. Okay. And one more. We have f is equal to 9, and u is 7, and n equals 1, so 9, 7, 1, 9, 7, 1, 9, 7, 1, 9, 7, 1. So that's 5, 35, carry a 3, 48, right? And all of those are distinct digits. So if we eliminate the restriction on a, and we said a had to be 4 in the problem statement, but if we eliminate that restriction, then we can find 4 more solutions for a total of 5 solutions. And that was the challenge part of this problem. So there you go. There's the problem and the challenge. And I have to make a confession. This problem I had originally written with 4 funs. So it was fun, 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 fun equals ball. So so I didn't realize that until last night, until the night before I was going to record this problem. And so I had to do some quick thinking or quick work to make sure it still worked. And luckily, it still had a solution, and it had a unique solution for a equals 4. So thank goodness for that. And I'll have to save the 4 times fun equals ball for another day, for another week. So there you go. Here are your numbers for when a equals 4, and these are the additional solutions for the challenge.